Hi, I welcome you to this video. My name is teacher Junju Isaac. So we have a question here of t equal to tan x by 2. Remember, this is a t formula where t will be given a substitution of tan x by 2 or tan x depending. So now when we have a question that shows that sin x is equal to 2t over 1 plus t squared, given t to be tan x by 2. So compare this is sin x, but what we have here is tan x by 2. So we are moving from a single angle to a half angle. Remember, in a double angle, where we had sin 2x, it was 2 sin x cos x. X is just a half of this angle here. So this is a double angle, but what is seen here is a half angle. We need to create a half angle. So when you have sin x, this can as well be written as 2 sin half of this is going to be x by 2 cos x by 2. So this is a half angle formula for sine. Now, the reason why I'm bringing half angle, because what we have here is a half angle. Tan equal to tan t is equal to tan x by 2. So this is a half angle. That's why I need to use this identity. So now we need to prove this. Now we need to create a tan here. We need to create a tan by dividing with something which is very important. Now if we divide it by 1, I have not changed the answer, the question, sorry. So if I divide by 1, remember that 1 is the same as sine squared, but I'm going to use half angle this time, plus cos squared x over 2. This helps me to create a denominator, then I will have to manipulate it and I get a tan, as you will see. So now from here I'm going to say that sin x is equal to 2 sin x by 2 cos x by 2, then divided by cos squared x by 2 plus sin squared x by 2. This is 1. I have not changed what I have. Now since I have a tan and what we need is to have a t, we need to get rid of the trigonometry. So I will divide it by a cos squared x by 2. We know that sine over cos is a tan. So when I divide it by this, both in the numerator and the denominator, I will create a tan. So it means that sin x is going to be 2 sin x by 2 cos x by 2 divided by a cos squared x by 2. Then down here we have a cos squared x by 2 plus a sine squared x by 2 divided by also a cos squared x by 2. So I have not changed. I am still with sine. I started with sine. Sine can be written as this. I divide by 1, it is still the same. 1 is sine squared by 2 x by 2 cos squared x by 2. So dividing by 1 doesn't change. So I divided with cos squared x by 2, both in the numerator and the denominator. Still the question is still the same. Now from there, let me create some space here. So when we divide this cancel and 1 cos will disappear. Then this will give us a 1, but this will give us a tan squared x by 2. So sine x is going to be equal to, now here we have 2 sine over cos, which is 2 tan x by 2, because sine over cos is tan. Then over down here, cos squared by 2 divided by cos squared by 2, you get 1 plus. Now sine squared x by 2 over sine squared x by 2. Sine over cos is tan, so this is going to be tan squared x by 2. So now from here we shall have to put a t where it is tan x by 2. So our sine x is going to be 2t over 1 plus t. This is now t squared, and this is what is required. So let us go to Roman numeral 2. So now we have cos x. If you remember where we had the cos 2x, we had a cos squared x minus a sine squared x, but now we are going to focus on half angle because this is x by 2. So we shall now use cos x to be equal to cos squared. A half of x is going to be x by 2 minus sine squared x by 2. So again I'm going to create a 1 down, and this is the same as cos squared x by 2 minus sine squared x by 2 over the 1 is the same as cos squared x by 2 plus sine squared x by 2. So this is equal to our cos x. Now from here I'm going to divide by cos squared x by 2 because I want to create a tan x by 2. So when I do that, I'll have cos squared x by 2 minus sine squared x by 2 divided by a cos squared x by 2. Then that all over, this will be cos squared x by 2 plus sine squared x by 2 divided by cos squared x by 2. So this is going to be 1 because cos squared x by 2 divided by cos squared x by 2 is 1 minus sine over cos is tan, and these are squared, so we shall have tan squared x by 2. Then when you come down here, this is going to give us a 1 plus sine over cos is tan, and that is tan squared x by 2. Now this is going to be equal to 1 minus, because t is the tan x by 2 from here, so this is going to be 1 minus t squared over 1 plus t squared. Lastly, Roman numeral 3, which is here, we are going now to find the one of tan. So now for tan, if t is tan x by 2, we are interested in tan, but remember tan 2x is 2 tan x over 1 minus tan squared x, implying that if we use half angle formula, the tan x will be equal to 2 tan x by 2 divided by 1 minus tan squared x by 2. Now from here we just have to replace tan x by 2 with a t. So our tan x will be equal to 2t divided by 1 minus t squared as required. So it is so simple like that. Now let us go to part B. So part B, now this time we have t equal to tan x. So now we can just use the double angle formula and we prove the same approach will work. So we know that sine 2x is equal to 2 sine x cos x. In part A we've been using half angle formula because we had x over 2, but now we are going to use the double angle formula. So now from here we shall divide this by 1, and the 1 we are going to replace it with cos squared x plus sine squared x. 1 is equal to this. So now our sine 2x will be equal to 2 sine x cos x divided by cos squared x plus sine squared x. As we've been doing, I'm going to divide this by cos squared x. So our sine 2x will be equal to 2 sine x cos x divided by cos squared x. The reason I'm doing this is to get a tan. So now divided by cos squared x plus sin squared x over cos squared x. So our sine 2x will be equal to, this cos cancels the cos here, so we get 2 tan over, now down here we shall get 1 plus tan squared x. So sine 2x will be equal to 2t, because our tan x is equal to t over 1 plus t squared. So that is the proof we have shown. So now let us go to the last one, cos 2x. So this again calls for a double angle. So the double angle of cos 2x is cos squared x minus sin squared x. So I'm going to divide this with a 1, and that 1 is going to be the cos squared x plus the sin squared x. This is the 1, you know it now. Now from here I'm going to divide by cos squared, both in the numerator and the denominator. So this will be cos squared x minus sin squared x times 1 over cos squared x. Then the whole of that, I'll be also dividing this denominator. So this is cos squared x plus sin squared x times 1 over cos squared x, so that we get a tan. So this gives us 1, because this divided by cos squared, you get 1, then minus sin over cos is tan, so sin squared over cos squared is tan squared over, this gives us a 1 plus tan squared x, but our t is equal to tan x. So we just come and we replace tan x with a t. We end up having sine cos 2x equal to 1 minus tan squared x, so it will be t squared over 1 plus tan squared x, so this is going to be t squared. So that is it. That's how we apply the formula, and we shall meet this further in solving equations, trigonometric equations. You may need this expression, these identities, the t formula.